Welcome back, welcome back. Welcome back, welcome back.
Draw yourself a
Taking it out.
picture. You get to pick what the picture is.
Okay,
And
I'm picking the
draw
pictures here.
like a picture in a nice frame.
Picture. Yeah, look at
I
that.
want it to be a pretty picture, all framed. And
Ooh, wow, look at that.
I'm going to draw five little monkeys.
Jumping on the bed.
These are sleeping in the bed.
You're the next Picasso.
All right, you can put anything you want on your picture. Don't
Those-
copy
Look at those
mine.
quality monkeys. Look
Don't
at
copy
those.
mine.
Mmm.
Of your own picture.
I think at the end of the year we should have show and
That's
tell. Yeah.
That's cool.
They're watching
Do a
you
big
while you
slideshow.
sleep at night.
Next year you have to present a meeting and
Fine.
say, have something to live up to.
Yeah. All right. We are going to put some tension on this picture, and the tension is going to go like this. Is this the one wire is going to go that way, and one wire rope chain
What if you had
Somebody
made
did
is
rules
going to go that way. You did it.
Looks like a TV with antennas.
Sorry, I'll have to
Can I
look
hang it
into
upside down?
Can I hang mine upside down? I forgot I didn't have enough room.
If you're going to do the whole problem upside down.
Yep.
All right. So
I'll just say it's mounted.
the picture is hung by two strings. They are at 45-degree angles.
Christmas please.
And we'll do two of these. Probably color would help on this. So let's see if I give you a... Did you take two colors and pass it on? Alex, take two colors and pass it on. Take any two colors.
I got mine.
Wow.
I got
Take
all
two
Thank
colors.
I'm obsessed
Okay,
with
hold on.
This is in static equilibrium. It's not swinging. It's not falling off the wall. It's just sitting there still. So I don't see a picture in here suspended that
Hey,
way,
the green
but
blue.
you've seen one, I'm sure. So we are going to look at the forces, and I'm going to say the sum of the forces equals 0 because it's in static equilibrium. And from there, I'm going to take a picture of all the forces. I'm going to use, we're trying to use red and blue if I can come up with one. I'm going to do the blue for the vertical forces. Once we go diagonal, remember that the tension is always away from the picture. So put an arrowhead on the top of this tension, representing the tension on from the string or the chain or cable or line. And I'm putting an arrowhead away from the object because tension always works that way. But as you know in physics class, we don't settle for diagonals. We always change them to their vertical and horizontal components. And this is where I want you to take one color and let's do the horizontal components first. So I was looking for a red. Let's see what I got here. Yeah. All right. So I'm going to do red. So this first, I'm going to call the tension in the first one on the right. I'm going to call that tension 1. And I'm going to call the other one tension 2. So whatever is providing tension, name them. So I'm calling the forces tension 1 and tension 2. I'm going to take tension 1 and divide it into its horizontal. There's one of the horizontal components, and I'm doing that one color. So make your horizontals one color and your verticals the other color. So then I'm going to go over here on tension 2 and notice that the horizontal component goes backwards, but the vertical one looks very much like the other vertical one. And is there any other force that I'm largely ignoring that I need to put up there? Any other force? Gravity, the weight of gravity, the weight of this picture is downward, so will that be a red color or a blue color for me?
Blue.
It is because it
Because
went
it's
downward,
up and
right. So, the weight is mg, negative mg. All right,
Just probably to the top of the right.
let's say, well, the weight, let's give it a weight. Let's say that it is 50 newtons.
Wow, that's a lot.
Heavy picture.
50 newtons. All right.
It's a heavy picture.
Yeah, it's a big old picture. All right. We're ready. Well, let me see if you got your colors in with your horizontal, and you didn't have to copy my colors, but make sure your horizontals are one color and your verticals are another. When you do it that way, you can easily see.
Dynamic or static?
Pardon? What's that? Still, it's not swinging or accelerating, I see.
Are you going Friday?
Colors, okay. All right, let me see your colors. All right, you got green going this way and blue
Yeah.
going that way.
Yeah.
Coolness. All right, green and blue.
Yeah.
Red and
I'll be
blue.
there.
Okay.
Turn it up. Wait. What are you doing on
Alright.
Friday? I just saw a picture and I'm like, I'm gonna win. Yeah.
Calculators out. We need to know some values.
Fundraiser.
And you'll recall that I'll give you the formulas. You actually
Is it here?
know the formulas. We'll put them. We'll remind you of the formulas. When we're doing the blue ones, we usually have 3 when something's hanging and 2 for the horizontal. We'll be looking at other situations where that changes, but expect 3 blue for me and 2 pink or red or whatever. So, what is the value of this one? Remember in trig, this is side opposite. So over here, I'll make the equation and I'll simplify it and I'll bring it back over to my picture. So I'm going to say this, since I'm working on the blue one, I'll write in blue. Sine of 45 equals opposite over hypotenuse. So in my picture here, this 45-degree angle, it's side opposite. I'll call this the y component, as I usually do. And I will put in y opposite over t1. So remember, our trig, side opposite, is always going to be used with the sine function. All right, so I'm going to solve that for y. So sine of 45 equals y over t1. So I'm going to multiply both sides by t1. t1 disappears from the bottom and appears over here when I multiply both sides by it. So now I know that that component is t1 sine 45. And we'll come back and improve on that in a little
See
bit,
that? See that?
because we know what sine of
Write it down.
45 is, but just leave
Write
it
it
like
down.
that. Now,
Sin
do I
45.
actually go through this who struck every time? I don't.
No.
My mind remembers that this is always this function, this tension times sine of 45. So guess what the pink one comes out to be? T1 cosine 45. So T1 sine 45 is my blue one. It's the vertical one associated with T1, and T1 cosine 45 is the value of the pink one, the horizontal one. So when you got those two labeled, I'm going to go over here, and you may be tempted to think that this is going to be T2 sine of 45 and T2 cosine of 45. It is not, because we're on a coordinate plane. So we have to remember, this looks like it's 45, but we start at the 0, the positive part of the x-axis where 0 is, and we go around that far. So it's not really 45 degrees.
180.
What is it? What is it, Emily?
180.
Well, all the way over is 180.
Oh,
So I stopped 45 short of that. So what is that?
135.
All right, so this looks like a 45, but it's masquerading. It's really a 135. So in your problems, they won't tell you that.
That's me.
All right, if you use 45 in your calculator, you'll get the incorrect signs, the incorrect SIGNs, the incorrect plus or minus, which you could adjust for, because you see this is positive and this is negative. So if you want to use 45, just remember to make the adjustment. If you use 135, the calculator will be faithful to you. All right, so this one is T2 sine 135, and this red one going this way is T2 cosine 135. And we have the weight downward is already a weight. If I'd given it to you in kilograms, you would have had to change it to a weight. But it's already a weight, so I don't have to change it at all. All right. I'm trying to find the whole reason we're doing this is find the tension in the strings. Find T1 and
T1
T2.
and T2.
That's the whole
Find it now,
purpose.
please.
Is find the tension in the strings. So, now that we have the setup, we are going to add all the horizontal parts and then all the vertical parts. So starting with the horizontal parts, I know that the sum of the, I'm going to work in red for the horizontal. If you want to work in the color that you chose for the horizontal, you may, but you may use your pencil as well. So I know the sum of the forces in the horizontal area are 0 because the object's not moving horizontally, it's still. So I know the sum of the forces horizontally are 0. What are the two forces? I have T2 cosine 135, and I have
Commercial
T1
break. We'll be right
cosine
back
45.
after a word from your local sponsor.
Notice I called